Okay, welcome to all guests who are joining this webinar. My name is Stefan van der Spek. I'm Associate Professor of Urban Design at TU Delft Faculty of Architecture, and I'm also Director of the VR Lab at the same faculty. Today we have a webinar in a series, the series of the VRDML, which stands for Virtual Reality Design Methods and Application Lab. So we started the series in 2020 with 3 VR in Architecture Month presentations, webinars. We continue with the series with the VRDML presentation, but it's important to say to the people in the meeting that the VRDML was funded by ClickNL, and that there will be new calls coming soon, and that there are meetings where you can join. So there's no content, no business meeting at the Immersive Tech Week next week, and you can join Monday, November 19, and you just have to sign up for this meeting. But for today, we have a meeting on the city at eye level. The city at eye level was originally started by STIPO, an urban design firm in Rotterdam, and they collaborate with Bart Hazen from BFAS, BFAS Plus, I have to say, to be correct, and Luc Goosen from the XR Zone, the former VR lab at the TU Delft. And they're both going to present for about 20 minutes. And after that, there is time for questions. So if you have questions, please post them in the chat. Well, this is the website of BFAS Plus, and you see they do projects in architecture, placemaking, and urbanism. And here, this is the website of the VR Zone, which will be called XR Zone Zoom. And next week, don't forget, we have a next session with Patrick Jansen from National University of Singapore. Okay, Bart, the floor is yours.
Virtual reality, a better city at eye level. Welcome everybody. A little introduction. My name is Bart Hazen, partner and architect of BFAS Plus. We do architecture, urbanism, and placemaking. For the past 10 years, we work in 3D, and the last 5 years we use VR as a design tool to develop our designs. And via this way, we had contacted STIPO and the TU Delft, and this was a real opportunity to go with VR to the next step. This we combined our VR team with STIPO, Sven, TU Delft, and BFAS ourselves. Sven, he was a part of our team at BFAS. He's very an expert on VR also. But he, yeah, okay. How to make an attractive urban environment. That is what we see if we look around. You see nice places to be, but there are also what you see in below. There are also spaces that you don't want to be. And how is it possible that still places still are there? What is going wrong? What we know is that the process in design is very complex. It's still being complexer if we look to the future. One of the most important things that we as office also we look at is the plinth. The plinth of the building is the most important thing. It's just 10% of the building, but it determines 90% of the experience. And we have a lot of tools to make the plinth nice, that it's attractive, that people don't only walk through, but really want to be there and want to sit there and talk there. So there are a lot of tools. You see that in below. You can add trees or pavements, or you have interaction with the plinth. You can model different heights to have more differentiations. There are a lot of tools more to use to make it an attractive environment. virtual reality. Yeah, what can virtual reality do to make those places nice? Is it only a nice experience, the virtual reality? No, we don't think so as an office. We really do think that it is a nice design tool because we use it every day in our architecture and in urbanism as individual designer. We use it a lot in the office, but also for a cooperation with the municipality or other advisors. It's a very strong communication tool, but also for people that live there, for participation in the environment. Those things are, how do you say it, general. But the next step, we think, as what we did with the VR team, is data analysis. That is really the next step in virtual reality that you want to research. First, in the beginning, we had 2D drawings, then we had a computer, then we had to do 3D design. And the last year, you see at the design that we use a lot of BIM data. If we put data in the design, that other people, other advisors, other people can use that data to make less mistakes. But I think that the next step is use VR. And that from the 3D data, we make an 3D environment, virtual reality environment, and we take from that experience, we take the data and we use it to the next level and put it in our next designs. These are some voorbeelden, how do you say that in English?
Examples.
Examples, thank you, Luc. I need you more. Some examples that from past projects that we did. This right above, you see Rijswijk. There was a lot of the environment thought we put a graphic on the wall, but people were not very enthusiastic in the beginning. So we made it in VR, and the people worked in it, and they were very enthusiastic, and we made it. This VR really was a tool to convince the people. Left below also, there was a lot, it's another project. People thought, oh, the street is so narrow. We have a problem. It was a lot of discussion, but when you go with the people in VR, the space looks bigger, squares look bigger, street looks bigger. They really experience what you would experience in real time. And you can't get that in with a picture. You really need VR to convince people, and then they see it. There's flat drawings, nice Photoshops. It helps, but virtual reality is really the next step to convince people of your design. Now I want to go to the research what we did with our team. We did two researches. One is the street in Sluisbuurt, Amsterdam, and the other one is bogaard in Rijswijk. And I want first to show the first research. This is Sluisbuurt. It's now in development. The municipality of Amsterdam, it's in the east of Amsterdam. And it's a precarious project because it's a lot of high-rise. The high-rise is a big discussion in Amsterdam because everybody knows it's a very historic center. This high-rise is a thing. Dus we had an assignment with Amsterdam to look in VR what VR can mean in this street, and what can it do to om het te verrijken, to make a good street. What we did, we started with some ideas. We had a brainstorm with our group. Dus what can we do to do research in these streets? And we talked about what can we do in design option in urban situations, Can we make a design option high-rise or not? Or how much detail do we put in the model? How can our target group understand the VR? Dus when we were thinking, we thought really, how can design influence the perception of the users at eye level? And what can we do? After a while, we thought really we must really make a realistic VR experience. First, we thought maybe we make some masses, because we make it very abstract. But we thought if the target group is very general, it are not designers, how do they understand it? This we said we do a lot of level of detail. We want social interaction. We want green, maybe wind, using a fan, or a test that people can really run on a treadmill to have a realistic experience. You see the bolts we really use. The other aspects were a bit too much, but that is the way how we thought. The next step was the modeling and the design process. How do you make this experience? Together, first we with the municipality we determined some aspects. What do we want to research? Building blocks, diversity and scale, the squares, the building heights. Building heights, what I already said, it is very important for Amsterdam in this place. We had also some street furniture and parking. We had, I think, 3 or 4 sessions with the municipality, and these aspects came out of it to research. We made a 3D model in Revit. We can do that very quickly, and we use Enscape. You see that on the right to have a really realistic impression of that. This way, we worked with the municipality through the model, and we had nice discussions. Then we built the VR. We did the VR research session, and Luc will tell later about it. But the Enscape we made, it was not good enough for the VR. We couldn't use it, so we did some other nice stuff to make it how do you say it, to have some data from the VR session. First, we did an intake, just some questions that people, did they ever already used VR or not, that kind of things. And then we started, and it were 3 sessions of 7 minutes. First, we started with a baseline. You walk through the model, to the VR environment for 7 minutes to see how it works, and that you know the way you want to walk. That was the first step. After that, we had 2 assignments. I see assignment 1 and assignment 2. And in assignment 1, group 1 had a design option. There's all the things that we had before, for example, green or not green, low tower, high tower, that kind of design options we had built in. And we hoped that people saw it and that we really could read it and read their opinion. After that, we had a survey, and we hoped from the experience that people saw the differences and if they liked it or not. Are those things important for the people? Do they want to stay? Do they like the space? That kind of stuff we wanted to get out that survey. The goal of the research was to also a general behavior in VR. We did, this is the first time that we did this. Is we want to first keep it simple. What is the normal behavior of people? Then we wanted to know what is the behavior of when we change the design options. And we wanted to develop data analysis in VR. That is totally new for us. And the TU Delft did a very good job, and it was nice and inspiration to work with them. And after that, we had the questioning and answers. And the question was also, can VR help in the design as a design tool? Then from then on, we had a little the enquête. Sorry, it's in Dutch, but this is what the people did say about it. They liked it very much, and it helped very much also for the project team and the plan team. And they saw directly that the street was more wider than they thought. This it was very nice to hear the conclusion from the survey. After that, with the team, we looked how we could use the data from the that came out of the VR session. Here you see one of the persons, one of the survey persons that walked through the model. And you see a part of the design in the square, and you see all of kind of dots and the roots, and that's all data what you see. Also above, other analyze systems you used to search for interesting data. There was made a script to do that research, and we had also heat maps. Because here you see the red spots are spots that people looked a lot, and the green less. This Luc will talk about it later also. This is data that we came out of the VR. Conclusion from that, because we made a report, and a very nice thing is the point is the first one, that most of the research group of the students looked at the most of the height of 1 to 10 meters, 28%. Looked at the plinth height. Because the plan team and the design team of the municipality did a bit less because they are designers, they're looking up. That is not the general person, they are the really designers always looking up. We think that it's very nice to see this, what I said in the beginning, that 10% is the plinth, it's 90% is the how you experience it. I think this is a good test that it's almost true. What was also very interesting is the corners, that people looked a lot to the corners of buildings. They were also red spotted, and that the students were interacting different at the area. They looked more at the walking people, because there were people walking around, cars driving, but there was also a playground with playground equipment. They looked more at those two to those elements instead of what designers do. They look at the facades, the architecture, and the environment. Just there were nice data. What did we learn of it? What we saw is we had the collaboration with the municipality, and they wanted to investigate a lot. Thus we had a lot of design options, but they cause us uncertainty. Another thing was that the research design options were general, and that causes also unclear answers. And the data of the design options was not well comparable, because the differentiation was the differences in time and position were in our walkthroughs different. We couldn't compare them one-on-one. And the last one is also important. The assignments, the last two runs, must be reconsidered, because there were assignments that the assignment was that people walk to a different point, but that was their goal, and it was too destructive. In the next research, we learned from this, and that's why we went a year later. We did a new research, the bogaard Rijswijk, and that is this spot, and it's a new development, and we could investigate this street. with the municipality of Rijswijk. And we had here also some interesting design options that we wanted to research. And this we learned from the past, and we had now a different research. We said we have still 3 walkthroughs, but we don't have assignments anymore. And to have really good measurements, we had kind of these 360s. Luc will talk about that, and we really can compare the data. I will show you, it's a lot of information what I talked to, it is a lot more, but to make it more understandable, I have a little Enscape session for you. So I want to end with that. So I stop this sharing. This then people understand more what we did.
Yes,
this is
we can see it. Yeah, it's in motion. There's
yes,
a slight delay probably, but that's okay.
Okay, it's graphical. This I don't here all the options are on. There's, for example, this stair, and one option, the stair is gone. And we wanted to see the interaction of people. This really people went up in this when this design option was on. Because you really see that you can manipulate people by design. And there were the 6 design options that I showed before. We incorporate this in this model. And it's not, this is not VR. It's we don't have the glasses on, so it's still flat. But this way you can see how we did the research. Another research was this canopy. Do you want it or not? Now the municipality first said we want it. It was a very important thing for them. In the VR, it was gone. They didn't want it anymore. This is VR is a very good tool to use. Also in the plinth, we want it open. In the other design option, it was closed because they didn't want open facades here because it had to do with the existing buildings that are behind it, or for example, the set back of the tower. We talked about that, and then we had also a passage that was an interesting design option, and that is the way we went through the model, and people walked and through the model and see. You don't see that here, but everything is standing still. But that was also the next step for Luc, that we really want to make an interactive environment. As there you see really the people walking and the cars driving. And this is where I want to end my presentation.
Perfect. So yeah, let's talk a bit about what we as TU Delft did. I understand there's a lot of TU Delft students and staff on this call as well. So maybe I can tell you something new as well. So yeah, we together with Bart and the rest of the team, we worked, of course, at the ideas for the Better City at eye level. And the main focus of our task was to work on the development of the VR application and the tools for the data analysis. So who are we? We're the VR zone, soon to be branded to XR zone, like Stefan already said. We're located at the central library, and our main goal is to, essentially we have 3 main goals: support education, support research, and do our own research and design developments. So we're open 9 to 5, Monday to Friday. Any student can come in. We have hardware here. There's 10 people of staff available that are happy to answer any questions that you have. So you're always welcome to come in for advice, brainstorm a bit, and learn and work with VR in any of your designs cross faculty. So it doesn't matter if you're architecture or maritime or aerospace even. We're always ready to help and brainstorm with you. And we also have our research tracks. So we work as a centralized lab compared to what Stefan is doing with architecture. We mostly work cross-domain now, and we develop applications for any kind of faculty or any kind of topic. And therefore our main focus is design rather than writing the actual papers. We're whereas specifically the faculties would have their own researchers who also write the papers and actually understand the data. We just provide the tools for them. So researchers are always welcome to come in, and then of course we do a lot of development, and we teach a course in VR development as well, a master elective. So there might be a couple of students. I actually started out at Stefan's course 5 years ago, so pay attention if you're a student, because I've been working at TU Delft for 4.5 years since. So yeah, there's something in you, in it for you if you pay attention. Okay, so let's talk about a bit about what we did in this process. So what Bart already explained is they started out with Revit and Enscape, and that works fine, especially as a design tool. The quick iterations that that process provides are ideal for designing and quickly showing what the differences are. But the main issue with Enscape is that it's a bit limited in terms of research potential. And that mostly has to come from the scriptability. So with Revit and Enscape, you can very easily show what's going on, but you cannot add different interactions to the software. So that's why we instead proposed going to a game engine, Unreal Engine. It's an open source game engine. Young people might know it because Fortnite's made in it, but it's actually very perfect for serious gaming as well, which essentially this application is. So using that, we could actually script within the application and actually talk a bit about or add a lot of different features, add a lot of different kind of interactions, make the world more alive, and also record a lot of data on the back of it. And then we used Grasshopper to analyze all that data, combine it, and because of course the data that you would get out is very raw, and then we had to interpret it as well. And we're not machines, so we needed to figure out a way for us to actually understand all of the results. That was years ago. Right now, we're actually looking into doing everything in Unreal and doing it all dynamically. So the data comes essentially during the research sessions, which is really cool because it allows for faster iterations. So what did we develop? We developed actually a bunch of custom tools together in this project. So first of all was the standalone VR application, which is essentially just a serious game. It's kind of a similar model to what Bart already had delivered to us in Enscape. And it already really helped us that it was an Enscape model because we could use it as a reference and just try to copy it wherever possible. And yeah, based on that, we just didn't just add the environment, but also did a couple of things that we could do because we had the scriptability, like add driving cars, add walking people, add sounds to the environment as well. So that's made the whole environment feel a bit more lively. Then second, we developed the head and position tracking tool. I'll talk a bit more about that tool later, but essentially it's just the way we record data and the type of data that we use for this project. We wrote a couple of Grasshopper analysis and statistics scripts. So all of the statistics were generated using Grasshopper, which I feel like there's a bunch of students who might actually use a bit of Grasshopper as well. So might be interesting for you as well to know that Grasshopper can be used in research like this as well. Then we developed a VR data analysis tool. Halfway through the project, we realized just looking at VR data on a screen might not be the best thing to do. So why not actually develop a plugin to load all of the data back into VR and analyze everything immersively as well? So we did that as well. And then for the second iteration, the picture didn't change, that's correct. We realized we cannot actually compare one-to-one, like Bart said, because everyone was free to walk their own route. We wanted people to be free to walk their own route and explore the city like we wanted them to explore it. But then the difficulty that you have is it's very difficult to compare what one person saw with what another person saw because their positions weren't exact, their timing was a bit off. So it was very hard for us to filter the data to be precisely the kind of data that we would need. So instead, we wrote a script to analyze the same kind of data from a fixed standpoint. And then all of the participants were free to, or they were put at a fixed position. They were given a couple of seconds to look around, and then we could actually compare one-to-one between a whole bunch of participants. What was the most interesting thing within that field of view that they were looking at? So that provided another very interesting layer of information. So let's talk a bit more about the head and position tracking that I mentioned earlier. So essentially, head and position tracking is a method for essentially a cheap replacement of eye tracking. Eye tracking is a technology used to basically detect what people are looking at. With head and position tracking, rather than actually measuring the eyes, you measure the rotation and position of the head. And the position of the head is important because we know the location of the participant within the map. And the rotation is important because we know what they're actually at least gazing towards. So there's a couple of pros and cons to using this technique. The most definite pro is the very high level of support, because essentially to have virtual reality, you either need 3 or 6 degrees of freedom in your hardware. So 3 degrees of freedom means you can rotate, and that's you can actually see what's happening. And then 6 degrees of freedom is not just you can rotate, but you can actually move your head sideways or up and down, and it registers that as well. And most VR goggles that are available right now already provide 6 degrees of freedom. So essentially any modern VR device would already give you the support of focus tracking. The second is it's very easy to implement, because all you need to do essentially is just get the position that the headset's focusing at. And that's a parameter that any application that you would use to develop VR in already makes public. So it's a very robust way of collecting data. Now there's a couple of disadvantages, or actually one major disadvantage as well, that has to do a bit with the accuracy, because you're not actually measuring what people are looking at, you're just measuring what they're gazing at. And yeah, because there might be people that rotate their eyes significantly more than they rotate their head in VR. And if you mostly move your eyes rather than move your head, we don't actually register that. So we noticed that this was a bottleneck after the first session. So we actually set up an experiment in the second phase, in the Rijswijk phase, because we noticed 2 things actually. One of them is people needed a couple of minutes, no more than 2 or 3, to just get used to how the headset worked. And when we just dumped them right into VR, the main issue is that the results of the first few minutes, they were very extreme, or they were very, yeah, they weren't in line with all of the other results that we were getting. So we want to have an introduction where people could get used to the VR environment without us directly and immediately recording the final data. And secondly, we wanted to know what the accuracy of the head and position tracking was. So we proposed an experiment, and we implemented it where people would just have to look at 7 boxes, and the boxes were placed around their heads. So they were essentially forced to rotate their heads all the way around and realize that they could just do a 360 rotation in VR, which some people only realized after 5 minutes in the first session doing the walkthrough. And then we would actually ask them, look at the cube. If they looked at the cube for 5 seconds, it would stop blinking and the next cube would start blinking. So they were instructed specifically to look at the cube. The center of the cube was our control point. And then we also casted a point in the direction that the goggles measured that they were looking at. So we kind of could calculate the angle, and therefore we could calculate the error. So what you see here is a scatter plot that actually contains all of these errors. And we did standard deviation on horizontal and vertical axis. And what you see is that the standard deviation horizontally is slightly bigger than the standard deviation vertically. So that means that especially in VR, people move their eyes mostly sideways rather than up and down. And once they want to move up and down, they actually start moving their neck. So we're talking about 9 and 6 degrees of deviation here, which in urbanism could actually be a little difficult to deal with. So we come back with, I come back to that later. Whereas for interior and architectural skills, this kind of deviation is actually very nice and very well within the margin of error. Of course, with a 6 degree deviation, the further away you go from your targets, the more inaccurate it becomes. So if you look at a 200-meter long street, it becomes very inaccurate. Whereas if you just look at a building that's maybe 20 meters long, you can quite accurately, not precisely, but quite accurately predict it, which means for architecture, you can use this technology quite well. Secondly, we could actually calculate these errors for each individual, because the second thing that we found is there were people with very low errors, sometimes 2 or 3 degrees, and there were people with very high errors, sometimes up to 15 degrees. So we could calculate for each person individually or each participant individually what their margin of error was, and then apply that to their data rather than do it centrally. So this way we could interpret the data slightly better. So for analysis, we actually had two different routes of coming up with all of the data. One is the statistics that we got from Grasshopper, and we combined it with the structured interviews that we did right after the session. And then the other was the kind of more difficult data to interpret. So that's the heat maps and the VR recordings. So rather than dumping everything into an Excel sheet and just looking at the results, we actually wanted to understand what was happening. So we built a VR analysis tool to actually look at those kinds of data and try to, with the entire team, we were there next to each other, looking at the results and trying to interpret what was happening. So for example, I'll show you the heat map, which if you look at the top left picture, you see kind of the raw data that we got, but then still presented in a kind of understandable manner. But that's not immersive, and that's very difficult to actually interpret. So then what we did is it's called baking. We baked all of that information into a texture that contains position data. And then in VR, we could project it onto the geometry and actually show in VR what people looked at, which is a lot more immersive and a lot more understandable than either one of the two other options. So that really helped us in understanding what people were looking at. And for example, using these heat maps, we figured out that people spend significant amount of time looking at corners. But then of course, there's other results that just fine to look at on the screen. Like one of them is the windrows. The windrows is essentially just what direction did the whole group of people look at mostly. Now, they were walking the street from right to left on this picture. So you would imagine they mostly looked into the left direction. But we could compare the results between the different participant groups and actually see if there were certain groups that looked around significantly more than other groups. And the same goes for the height, where we could actually calculate the average height, essentially the categorized heights that they were looking at based in just the altitude of the points, where Bart already told you a lot was between 0 and 10 meters. So that was very important for our research. But yeah, there's a couple of problems with it as well that definitely need to be taken into account when setting up something like this. Once the accuracy, especially at an urban scale, you're dealing with a margin of error that's definitely not insignificant. So you can include that in your results. You can actually include the error bars now, but still at some scale, you might want to go to the eye tracking, which is now much more available than it was, I think, the 3 years ago when we started this project. So that's an important thing to note. If you do research like this, it's actually worth your while to invest in the hardware to actually give you the accurate data. Also, the target groups, of course, we were working, half of our participants were involved in the design of the environment. And it was interesting for us, especially because of the experimental nature of the research, to see what the difference was between people who were involved and people who weren't involved, even though the people who were involved still didn't have the experience with the VR model as much. But of course, if you want proper research, you need to look at the target group that's a bit more representative. So for further research, those are things to have to be taken into account. But then we also came across a couple of funny things that happened along the way. Like if you have driving cars and you program them and there's a bug in your program, the cars might crash and they might end up against the tree. And then a participant all of a sudden might stop the entire experiment and just stare at a car that's upside down against the tree for 5 minutes and ruins your data that way. Another thing that we realized, one of the optimization tricks we use in VR is we just duplicate assets wherever possible. So one of the things we duplicated was the people walking around. The main issue was essentially just one man wearing different t-shirts. And a lot of the female participants told us that they really didn't like this one scary guy who was everywhere, and he was always just wearing a different t-shirt. So if you're asking about the level of comforts you experience within an urban design, which we definitely were, that's something that can drastically influence it. And we introduced it, so then we also need to know how to handle it. So from now on, or from this research on, we always make sure to include stuff like that. And then Another thing is that Dutch people on average are pretty tall. So the people that we used were global average height rather than Dutch average height. For Dutch people, that kind of felt like everyone was really tall or they were giants. So that's also, especially when trying to interpret skill, VR really helps with interpreting skill. But once you add reference models to your map, and you add references, for example, people that have a pretty well-defined height, you might actually end up, confusing people a bit about stuff like that. So those are all things, especially because of the level of immersion, that start to count at this kinds of experiments. So yeah, that was my part of the presentation. Let me know if you have any questions.
Okay, Bart and Luc, thank you very much for these presentations. I really like the way you talked about the project, because of course I've seen presentations before, but I think you've really made a step forward by adding some slides and adding to the story. So yeah, great presentation from my point of view. And to say about the confusing part, yeah, I fully agree with the people you place in this kind of environment. So the last project we did, we heard that people were too nice, too beautiful for the kind of environment, or the cars didn't fit to the environment because there were beautiful Audis and BMWs, and the kind of neighborhood wasn't like that. So it's very important the kind of assets you use. So yeah. Great that you had the same kind of experience. But I assume the audience has some questions as well. And I see a first question from Jan Feng. Jan, can you ask the question yourself? Can you unmute yourself? And yes, perfect.
Yes, sure. Can you hear me?
Yes.
Yeah, great. Thanks both for the presentation, and I have a question for Bart, specifically because I really like the idea that you can examine how people view the design point in the virtual environment. And I just wonder, would it be also interesting, maybe already involve like citizens in the design process in the VR environment, instead of just to say how do they interact or react to the finished design in the virtual environment. Like, for example, I don't know, maybe there's a community and you have a different type of trees, and you can ask the participants to say what kind of trees they would like to put in the virtual environment, and maybe there's different consequences of you putting different plants in the community. Then people have a more direct feeling of, actually, as people living in that community, what is the good design.
Yeah,
and maybe, and I just have a quick follow-up question for Luc, and I wonder how difficult is that to actually make that into an application.
The thing is that what you ask is we do it already. It's the past 5 years. We use Enscape, and you put the glasses on and you have it in VR. And we can make the design options in Revit, and we can really change them. This, sometimes we can make some design options and we show it to our client, and they say, now I understand. Just, you can do that really good. But what we here want to do is next level, that we really see the data, because then you are talking with people when you show it, and then you convince somebody, and then it's done. But we want to do something new, just that we really make something what is not yet built, and we show it to the people, and we don't want them only their opinion, but also the real data, what is happening in the head, what people don't know, because otherwise you are, how do you say it? You put a route into the people. You say, watch to those trees, and then they look to those trees. But now we really want that they experience that, and we want to look what happens, and if people see the differences in the design options, and what does it doing to people, and that is what we wanted to do today, to show today.
Yeah, indeed. And I wonder, like, how do you show the consequence of the design in the virtual environment. For example, if you put a light at a certain place, it might be attract more people, or maybe even will be people like a bike through that street. And I wonder if you have any like kind of thoughts regarding this.
Yeah, there's everything what you in the first session we did a lot, but we couldn't, because it was so much, we couldn't really say what did it now, was it the light or was it the bike? We couldn't really say. In the second research, it was easier, because we really had that people would be on that one spot, because we really could compare the design options. And for example, what we noticed in the first session, one person was on the balcony. Yeah, we put one person on the balcony, and we thought later on, why is everybody looking at the balcony? Because there was a person on it. And that's our funny things that we didn't, it was not our meaning, but it happened. And that's just nice to see how VR reacts. And that's interesting. I hope I answer your question, but.
Yeah, I think you did. I think, do I need to give other people chance to ask questions? I feel I'm asking all the time.
If there are other questions, but to answer, to summarize Bart's answer, I think the main line is that next to what people say, the response you get in the questionnaire or in the interview, what people tell you, is that you also need the data. So there is more to gain from the VR than just the response from people, because there's an underlying unnoticed part by the people, and that's a part you want to collect as well, either by looking at where people are viewing, or by measuring things like heart rate, breath, other ways of their reactions, because their words, their translation into words is not always the complete message. There's a lot underlying, especially if you're using noise, you're using this kind of people, they react on that without saying. Yeah,
that's good that you say it, but we didn't tell that. But when the people had experience, we had also they had how do you say it, the headphones on with city background sounds. The speaker really
noise.
Yes, they really thought they were there, and if there was a car passing by, they heard it. It was a very nice experience.
There was a school, and then you would hear the school children play outside of the school. So we really made sure that the environmental sounds, and that's again one advantage of going to a game engine, where you can actually have those sounds fade in and fade out depending on where they are.
Yeah.
Look, maybe you can also answer Jan's question, because he also had a question for you.
Yeah. You were asking about developing an application to see what kind of trees people would like in a street.
I mean, just in general, like I think I had a discussion with you and Arno before. If I want to invite people to co-design some object in the environment, and of course, if you want to scale the project or you want to place a project, object in the environment, I think it will be much difficult to develop, and I think it also requires much computational power. So I wonder if you have some.
Yeah, it is possible. Actually, the funny thing is the answer is definitely yes to both. The specific example with the trees, we just did a project with Wageningen University where we modeled the street, just a typical Dutch residential street. And we placed 16 different kind of trees based on conjoint analysis in there. And then looked at the kind of features that people liked about those trees to kind of come up with the ideal tree to place in that street. The results of that were presented yesterday. So it's really fresh. The second thing, I'm actually developing an application like that myself, where you can move the stuff around in VR with multiple people at the same time and interact like that. So yeah, it's definitely possible. It's difficult to develop, but it's definitely possible.
Yeah, and I'm just curious, for application, are you like building some like toolkits, like you have different options? Then okay, yeah. Oh, great. Yeah. Thanks.
Stefan, you're muted.
I think you're muted, Stefan.
Yeah, now it works. I need to use the spacebar, but it wasn't working. Probably I was typing somewhere else. Okay, I saw another hand there. I think it's Yasuda. Can you, or someone else who raised a hand or not? No? Well, I have some questions as well, but I know the project, so.
Uh-oh.
Okay. Bart, maybe you can explain what do you bring to a next project? So you have used VR now from Enscape as a direct tool for the designers, you could say. You have used the more functional VR with using a game engine. What would you say to other designers? What could they bring? What do you bring to the next step of design? Well, how could it help the designers?
I think the next step, the next step is to widen this research, because this is a very little piece of what we can do, and this is just a start. Because I think you must, it's like BIM. BIM is also developing its data. This first, it was always sensing, making nice stuff, but it was not, there was no data in it. It is, well, what can we do with that? And because designing is in time, it's more complex. This now we have durability, green. We have more rules. It's all complex, and I think VR is really a tool that can help us to understand everything better. It's a communication device, but I think we really can also use the data. And this is what we did now. It's the beginning. And I think when we get really precise, we can understand people better in the surroundings. What is a nice place to be before you build it? And that is a nice thing. This, it's not yet there. Just test it in VR and then build it. And then the chance is there that it will be good.
Just to expand a bit on that, we also developed a tool actually as a continuation based on this in residential architecture, where we started measuring how often people look at certain objects. So as an additional layer of information for a similar project like this, for example, we can actually start counting how often people spend time looking at trees or at cars or at facades, and actually start distinguishing that specifically, rather than right now where you just heat map it. Actually getting the names of those objects and get them fitted to actually statistically analyze it, that could give us a next level of additional information. And as well, then at some point you start tweaking those objects and see, what if I change this? What if I change this? How will it influence the overall?
Yeah, what is interesting, for example, is it was a design option, the height of the tower.
Yeah.
Nobody saw it.
Even
you have a lot of discussion, but nobody saw it. Only designers. They looked at the top, but they
didn't notice the different heights even.
No. This general people don't see it. This why that kind of discussion? I understand the discussion, but is it really necessary?
Yeah, but usually if you draw a plan, so I remember making urban plans in the mid-90s, and the discussion was always about the highest building, because if you drew the section or you had the 3D model there, or the model, the maquette, then it always started about how high is this tower, is it 50, 70, is it 100 meters? It was always about this highest building. So are you missing a discussion now, or do you think that the discussion has shifted to a perspective which is more important?
Yes, the last one. I understand the first one. You must discuss because you have other reasons, a wind or a site at a distance. I understand the discussion. But I think we must really, to make an inclusive city, the city at eye level is very important, and VR is the tool for it to test it.
Yeah. maybe to close, Luc, do you have anything to say to our students? So some of them are still in the meeting, some of them will watch this video later. So is there any tip you can give them to use the VR in a smart way?
Well, start now is the smartest thing to do. You all have access to Enscape. Don't wait until the last week. Actually do start using VR as soon as possible. Doesn't matter if your design is just a bunch of cubes in Rhino. That already gives you a lot of interpretation, and it's much easier right now to just change the width of a street while you're still in a very early process than when you are in a later process. One of the tricks that I really do think does help is making sure you have some reference in terms of skill. So what I typically recommend is splitting every building mass essentially each 3 meters. So you start recognizing where the floors are. And based on that, especially in Enscape, just put a different material on the next floor. It's one of the quickest things to all of a sudden realize how wide a street is. And if you're just looking at a blank mass, you don't really, you can notice it, but it takes a lot more effort. So I think that's one of the quick tips that I can give. Start now and make sure that you have a skill reference in there.
Yeah, and I think the last part you mentioned is most important, because with the big white building blocks, you don't have any feeling about scale, about size, the height and the width of the street. So you really need something to understand the width and the different heights there. And that was one of my questions indeed. So you answered that. So that's great. And regarding the starting, actually they started yesterday with the project, and I had the first view in Enscape, and I hope they will lend our headsets tomorrow when we bring them to the studio, to the atelier. So, well, I think it's time to close this session. Again, I want to thank you very much for your presentations. I think they're very helpful, and it's just great to see this project again. But also as a very nice story. I hope everyone liked this. And well, next week we're back with computational design thinking by Patrick Janssen. It's a lunch meeting, and I hope everyone will join again then. So thank you very much, and then goodbye.